Hello, everyone. Thank you for joining. This is Jamal Arif, and I'm part of the Oracle Cloud Infrastructure team. We are continuing on the series of Container Engine on Kubernetes, and in this video, we are going to talk about how do you create a cluster in OCI. So before we actually go on and create a cluster, there are some prerequisites that we need for creating a Kubernetes cluster in OCI. Number one is that like by default, there is a limit of 3 clusters per OCR region. If you have the monthly universal credits or if you're using the pay-as-you-go promo accounts. You also need to have some quota on the compute engine size, because as you launch your Kubernetes cluster, if you want to launch additional worker nodes, you need to have some kind of quota available for your worker nodes. Now from an IAM policy perspective, like every other service, the OKE service is also very tightly integrated with identity and access management. So for the so Before we actually create the cluster, there is a specific policy that needs to be created within the root compartment of your tenancy, where you allow the service OKE to manage the resources on your behalf in your tenancy. So there is this statement which I'm showing on the screen needs to be put in the root compartment, and you just need to allow the service OKE to manage all resources in tenancy. In fact, let me actually switch to the console and I'll show you some additional like individual IAM policies that you need to launch a Kubernetes cluster. All right, so I'm logged into my console. I'm right now on the home page. I am in the Phoenix region. So if I navigate to developer services to container cluster is OKE. Over here at the top, you can see that there are some basic requirements which is listed out. So if I click on the cluster requirements, I can see that the first requirement is to have a policy in the root compartment of your tenancy to allow service OKE to manage your resources in tenancy. In addition to that, if as an individual user you are not part of the administrator group, then your user needs to have the following individual policies as well. So basically, have the manage policy, manage level on the instance family in your own compartment, have the ability to use the subnets, read the virtual network families, use the virtual NICs, and so on and so forth. Once you have the right kind of policies, you can then go on and create a cluster. So for creating a cluster, just click on create cluster. You can define a name, the Kubernetes version. The two that we currently support are listed out here. And then there are two options to create a Kubernetes cluster. You can go ahead with quick create or custom create. The quick create is a quick option of creating a Kubernetes cluster where you don't have to create a virtual cloud network and previously or some like prerequisites are not required. It actually would create the networking resources for you quickly. So for instance, if I go ahead and if I select the quick create, I can see in the virtual cloud network or network resources area, it's already pre-populating and telling me that a new VCN would be created in this compartment. So there would be one VCN, one load balancer subnet, and one worker node subnet. Both of these subnets are regional subnets. That's why these are like just one subnet is required. You can have private worker nodes or you can have public worker nodes. I'm choosing to have private because it's always recommended to have your compute workloads or worker nodes as private. Now, next we define the node pool. The node pool is basically telling me what kind of individual worker nodes would be launched in my Kubernetes cluster, where my actual pods or container applications would be running. So for instance, right now, the node pool is defined as the shape of 1.1 virtual machine, and there would be 3 number of nodes. So across the 3 availability domains, these 3 nodes would be separated out. I can also choose any other virtual machine shape that my tenancy has access for. So for instance, if I have any bare metal nodes, they would also show up here, and you can add the create bare metal nodes as your worker nodes as well. If you go scroll down a bit down, you can provide the public SSH key, which basically would allow you to directly SSH into the worker nodes. And you can also add in Kubernetes labels. The labels will automatically be applied to those individual hosts, and then when you are deploying your container application, you can put that label in your YAML config of your pods. When you're deploying the pods or deployment, you can put that label, and the Kubernetes would then take care of deploying the application only on those specific labels. So you can add additional pairs as well as you go along, but you can add the Kubernetes labels. And then there are a couple of additional options that we automatically allow as well, which is Kubernetes dashboard, which is enabled, and the Helm is enabled as well. Once you have Helm enabled, you can easily manage your Kubernetes resources using the Helm Packet Manager. So click on create. So it first creates the network resources. So you can see it has created the virtual cloud network. There is also a NAT gateway which is created because of my private workloads. So in order to connect the private workloads with internet, you will need a NAT gateway. So it has a NAT gateway as well. It creates the required route tables. It creates the required security lists and add these security rules in there as well, the required subnets, and then the cluster is created. So now the cluster is in the creating mode. I'll just stop the video for a couple of minutes. It doesn't take more than like 3 to 4 5 minutes to create the cluster, and once it's created, I'll just start the video again. So the cluster is active now, and you can see the details on the details page. So on the network information, you can see the VCN name, the quick cluster that was created, and the new VCN which was created alongside with it, the pods CIDR range, and the service CIDR range. So these are internal Kubernetes CIDR ranges, the CIDR which pods would get, and if any services are created, what's the CIDR the services would be assigned. And then additional details on the load balancer subnets that were created in the VCN. The Kubernetes variant, where the Kubernetes cluster exists right now, the complete details of that, and then the node pools. So currently we had node pools which were based across the 3 ADs. So you can see AD 1, AD 2, and AD 3, and it also lists the subnet. So basically it's the same regional subnet across the 3 availability domains and the 3 nodes. Once the master is active, you can see that on the worker nodes, they have started to come up, and now it's installing the basic software like container runtime of Docker and additional software related on the Kubernetes cluster. And once it's available, it would change the sign to active. There is no public IP associated with these nodes because these are not public subnets. These are only private subnets. On the left hand side in the resources section, you can see details of any work requests, which basically show you what are the APIs which are being called to create the cluster, and any individual components like node pool create and cluster create. In the quick start, it gives you some additional details, like how do you access the kubeconfig file, how do you then use that kubeconfig file to directly get access to the cluster using something like kubectl, and see the kube versions or just create a basic application. It also gives you a quick link to how do you access the Kubernetes dashboard. In the next video, we'll take a look at how do you connect to the created Kubernetes cluster and how you can access the Kubernetes dashboard. Thank you once again, and please join us in the next video.